Hi, we are Indian Brothers, and once again we have come out with our stability classes over here. In our previous class, we have identified that what is the exact location for our given S plane over there, and we have described that the location of the pole is in the origin, or if the two poles are at the origin of our S plane, then what should be the response for that given consideration over there. And we have considered that the input for our given system will be our impulse response over there. Now in this case we are having our the pole is placed at our considered point of 1 over there. Then what seems to be the transfer function in this case? According to the definition of our transfer function, we are having Cs divided by Rs, and the equation seems to be our 1 divided by our S minus 1. And if you just do put the poles according to a definition for our pole 0 plot in our previous occasion, what is the exact method to have the poles from this given diagram? If you just do say if the denominator portion will be 0, then we are having S is equal to 1, and the location of the pole is exactly at the position of our 1, or at the 1 position over there, and that is being reflected over here. And according to our S plan, we do know that this is our considered part over here. And once again, if you just do apply the much needed impulse input over here, then we can say that the Rs will become 1, and after that, if you do put this given equation over there, the equation will be Cs divided by 1 divided by Cs is equal to 1 by S minus 1. And once again, if you just do apply the inverse Laplace on this given S equation, we are having, if you just do apply the inverse Laplace on this given equation, we are having Ct, and the equation will be our e to the power t. Okay, so this is our considered part over here, and we have plotted that in our Ct versus t diagram over here. And after we have plotted, we can see that the curve is look like this one, and it has started from our 0 and it is going towards our infinity over there. And if you just do increase the time, it is actually going towards our infinity over here. Now, quite naturally, we, according to our definition for our Bibo analysis or Bibo analogy, what is the Bibo analogy? Boundary input, boundary output analogy over there. We have analyzed that, or we have applied the much needed considered bounded input over here, but we are not having our bounded output over here. Why? Because if you just do increase the time as t tends to infinity, the output will approach, or output will reach to the infinity over there. Now quite naturally we can say that the system will be unstable over here. Now we are having our quite simply a step over here. I am just going to refresh that step over here. First we do require to find out the transfer function just by looking at this given S plane over here, and in this case we are having Cs divided by Rs, which is our system diagram over here. And according to that open loop system, we do know that this is our Gs that actually do give us the transfer function over here. And in this given case, the input will be Rs and the output will be Cs, and we can write that in our block diagram analogy over here. So quite naturally the Gs will be our, this is our system diagram over here, and we have plotted that at our S plane over there. Now quite naturally Cs divided by Rs, which is 1 divided by S minus 1, and according to the S plane we have plotted that over here. And how do you know that? If you just, according to our pole 0 plotting over there, if you just put the denominator portion as our 0, that actually gives us the pole. And if you just do put the denominator portion that equal to 0, that actually give us the plot for our poles over there. And according to that considered part, we are having that the pole is placed at our one portion over there. Now just by looking at this diagram, we are having this transfer function over here, and in our next step we do require to apply the impulse response of that given equation over there. And I have put that in our given format over here. Quite naturally, Cs is equal to 1 divided by R is minus 1. Why? Because after we have applied the impulse response on that given upper equation, we are having Cs is equal to this one. And in our next step, if we just do apply the inverse Laplace on that given equation, which is this one, we are having Ct is equal to e to the power t over here. And let us just consider what seems to be the output response with respect to our time over there. That actually do give us the consideration for our stability, and we can comment on that over there. And after this one, we are having, this is our given equation, and if you just do plot that in our given waveform, which is Ct versus time, we do realize that after, if you just do increase that time, it is keep on increasing over there, and quite naturally that is unstable. Why? Because we have realized that this one will be the characteristic or nature for our bounded, not the bounded output over here. After we have applied the bounded input, we are not having our bounded output over here. Why not bounded output? Because we cannot define that output over there. It is keep on increasing. If you just do apply the time tends to infinity, the value of Ct is keep on increasing with respect to time. Now quite naturally, as we are not having our bounded output in this case, we can say that this system itself, which is the pole that is placed at our point 1, that is quite naturally unstable over there. So this is the system for our consideration according to the location of our poles on the stability over there. Now we can say that the system is unstable. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section for better understanding. Do like, do share our videos, and keep following our channel. That's it, and thank you and goodbye. If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates, and stay tuned to the channel. Thank you and goodbye.